Hello students, in today's class I wish to teach you the concept of integration and differentiation. Integration and differentiation, we'll start with differentiation first. Actually these two are the two mathematical tools which are similar to our binary operations what you have studied earlier. Earlier you are familiar with these operations, right? Plus, minus, into, division, these are called as operations, arithmetic operations. Similarly, extension of these two operations is addition of two more tools. Which tools? These are called as integration and differentiations are called as the mathematical tools. For what these are applied? Actually, differentiation is a process of dividing a bigger element into smaller parts. Integration is a summing up of smaller elements into bigger parts. Nothing but addition and division. But earlier we divided some kind of an object which are called as regular shaped object. Now if you have some kind of a length like this, you can divide this into two equal parts or four equal parts like this. Similarly, each part is called as a small part. Summing up of all the small four parts, that is 1, 2, 3 and 4 gives rise to bigger one. For all the regular shaped bodies, we call that in terms of summation or addition. Whereas the same concept when it is applied to some kind of an arbitrary shape like this. What is the shape? There is no regular shape like this. Now, if you want to find how much is the total size of this or how to get the total entire part of this, for that we now divide this into very large number of small parts. If the total length is x, the total length of this is x, this arbitrary shape is x, the smallest part of that is called as dx, which we term it as differential part. Like that, how many such differential parts are there? 1, 2, 3, 4, like that n parts are there. So summation of all the small parts is actually giving rise to total value of x. I am just telling you the basic outline part, like what is the meaning of differentiation. We use the concept of division onto any kind of an arbitrary shaped element. The process in this concept is that we have to divide that arbitrary shaped element into a very large number of small parts. Each part of the small part is called as a differential part. What is it we call it as? We call it as the differential part. And we divide that into n small parts. Summing up of all n small parts. Summing up of all n small parts of arbitrary shape is called as integration. Dividing this into very small parts is called as differentiation. Actually, this is the mathematical tool which you learn in your mathematics in second semester of maths or first year, PUC 1. But in physics, we need this tool to understand it early, because when we are dealing up with third chapter, we do come across the terms called as displacement, velocity and acceleration. We actually need these tools of integrations and differentiations to understand or to get the things of velocity and acceleration from. By knowing one, you can determine the other. Now in an outline in simple form, you no need to remember any concept behind this, no need to understand, no need to by heart any part behind this. Our job in this physics part of integrations or differentiations is that we should get the formulas of these things properly. I'll be now giving you all the formulas. Those formulas you should remember, and all the formulas are also based on the first formula only. We have to remember this first formula in the form of like how you remember your old formulas, a plus b whole square formula, or a plus b into a minus b formula. Like that, some like action is equals to minus reaction, Newton's third law. Likewise, how you remember that? This first formula of differentiation you should remember, or you have to by heart that and what that formula. Now this is the way how we represent differentiation. In differentiation, the symbol of differentiation is this one. We write that in the form of d by dx, where we are dividing one function into differential parts like this. What is this function? A function is that it will be having some numbers with that in the form of variables. What all the right term you write here, this function is a variable in this term. Sometimes you write like this, d by dt. Sometimes you write like this, d by dy. Here you have some function. That function is a variable in time. Here you have function. That function is a variable in y. What all the function you have? What is a variable? What is a variable? Variable is that whose value changes with respect to, for example, if you have x is equals to 9t square plus 7t. Clearly in this equation, if I substitute t is equals to 0, I get x is equals to 0. If I put t is equals to 1, 9 plus 7, it is 16. At different times, position is different. Writing an equation like this is called as, now this equation is depending on time factor. Since it is depending on time, the variable here is time. It is changing equation with respect to time. That is what we say in this function, there will be some variable and we differentiate this function with respect to that variable. Now you people no need to by heart or get the anything behind this. Just if you know this part of the differential formula. In differentiation we have the formula of d by dx, where d is followed by the function. Function will be having a variable with that. That variable is the one what we are going to divide. If it is a t variable, I cannot write dy by dx. You cannot differentiate that. If it is y variable, I cannot divide with x like that. If it is y variable, differentiate with y. If it is time variable, differentiate with time. If it is x variable, differentiate with time. With x it is. In that way it is. So I just remove all this part. I'll just give you the formulas first. Let's go ahead with the formulas. Once you are clear with the formulas, we'll do one example. Today I'll be confining only to differentiation part. In next video, I'll do with the integration part. I first want to teach you these things. Actually, we want this tool of differentiation to get the concepts behind it. Displacement to velocity, velocity to acceleration. I have erased this, but it is still C. Okay, accordingly. What is the first law of differentiation? D by dx of x to the power of n is equals to n into x to the power of minus 1. You have to remember this formula. Now, we'll write some more formulas like this. D by dx of x is equals to, in place of n, if nothing is there, it is said to be 1. Substitute that 1 in this, you will get the answer for this. 1 into x to the power of 1 minus 1. 1 minus 1 is 0. X to the power of 0 is 1. 1 into 1 is 1. D by dx of x is equals to 1. This is the formula what you should remember. And next formula is that d by dx of x square. In place of 1, you have to substitute 2 in this. 2 into x to the power of 2 minus 1 is equals to 2 minus 1 is 1, x to the power of 1 into 2x, that is 2 into x. And you can remember it like this. When you have square terms, that power will come as a magnitude and power would reduce by 1 time. I am repeating. If you have power terms, power would come as the magnitude. This is question, this is answer. In that way it is. If you are differentiating x square with respect to x, answer is going to be 2x. Similarly, you can write now the fourth one, d by dx of x cube is equals to, answer is 3x square. You should understand why it is now. Power has come as a coefficient and power has been reduced by 2. That is the way how it is. Next formula, d by dx of some k into x, where k is called as some constant. K is called as any constant. What is constant? Any number it is. 5, 4, 10, 13, whatever it is. Accordingly, if you have that one, constant will come out differentiation. We write formula like this. D by dx is equals to, d by dx from this formula is 1. Accordingly, k into 1 it is, which is equals to k. D by dx of k into x is equals to k itself. That means, example, d by dx of 10x is equals to 10. D by dx of 20x is equals to 20. We should remember the formula like that. 5 formulas are up. Sixth formula, d by dx of x to the power of 5x square. Let us say it is 5x power 3. This is a combination of all different formulas. X power 3 is this one and 5 into x power 3 is from this one. Combination of these two put together it is. So when you have something like this, what all the constant you have that comes out of the differentiation, that is 5 into d by dx of x cube. And what is the answer for d by dx of x cube? You will get this in the form of what? 5 into 3x square. Can I write like this, right? X cube differentiation is 3x power 4. It is equals to how much? 15x power 2. So when you have this one, I told you, power will come to the coefficient. That is 5 is already there, 3 will come here. What is 3 times 5? 15, power reduced by 1 time. 15x square is the answer for this. This way, you should remember as the formulas. It becomes easy if you have more practice on this. And some more formulas, what you should know is that d by dx of 1 by x is equals to log of x. Just remember the formulas as of now. We don't know when we are going to use that. Whenever the examples come in the chapter, we'll use those formulas then. At least now, for some time being, remember this formula. D by dx of e power x is equals to e power x itself. Next formula is ninth one. D by dx of sin x is equals to cos x. 10th one, and the last formula for today, d by dx of cos x is equals to minus sin x. You may get some more formulas. There are so many formulas in the textbook, but right now we don't need all that formulas. We need only the formulas related to some examples. For this chapter point of view, only these formulas are needed. If any other formula where we need, we can just refer the textbook for the remaining formulas. Many formulas are the infinity formulas will get like this. You can write as many formulas as you want. Once we need, as per the requirement, we can write these formulas. Actually, now by knowing this, you can do some what else, what we want in physics about these things is that I told you already that you will be given some kind of an equation in terms of displacement, and you will be asked to find what is its velocity, and if you know velocity, you can also find what is its acceleration. These things what I'm trying to tell you is, by giving the equation of displacement in terms of time, you can determine its velocity, you can determine its acceleration. So what all we have learned so far is that formulas of differentiation. Now I want to tell you how are we going to apply those formulas. You have to by heart formulas, at least one you should by heart. Once you by heart that, you can do many other things. I just want to give you an example to understand the entire concept. If you know this, what I am telling now, that is sufficient. What all the past things we have listened, recap that, but try to follow this what we are telling now. Actually, why do we need is that we are doing a third chapter, which is the motion in straight line. First of all, what do we mean by motion? Movement of the object. Or we say that physical body has two states. There are two states for the physical body. One is called as a state of rest, other is called as a state of motion. If it is in motion, again it can have two things with that. That is uniform motion and it is non-uniform motion. So with respect to the state of motion, state of a body, or rest state of a body, or motion of a body, we need to now understand, we will be dealing with these things called as what? Displacement. This is the order what you should remember. First of its kind is displacement. If you take next term of that velocity, and then we want to understand these things of differential integration to deal with these concepts of velocity, displacement and acceleration. Kindly adjust my spellings. Okay. How are we going to understand is that actually, to relate between these two, there are two ways of understanding this one, called as calculus method. Other one is called as graphical method. Hopefully you have some idea about the graphs, or in graphs we deal with again three kinds of graphs. One is called as displacement time graph or position time graph, other is called as velocity time graph, and this is called as acceleration time graph. You can convert from one to the other, this to this, either of these two processes. And what are two processes? One is called as calculus method, other is called as graphical method. In calculus method, there are two things called as differentiations and integrations. Whereas in graphs, again there are two things called as slope and area. If you are clear, if you have some knowledge on the graphs, there you will get these terms called as slope and area. If you don't know, I can also make one more video on this at a later stage. Once I complete these two, I will take this part also. Now, what I am trying to tell you is that we have to learn this. To get this from this, we should know either of these cases. We will be learning all the four together, one by one. Today we are dealing with this. Tomorrow we will take up this. Tomorrow and then. So all the four videos I am going to upload very soon regarding all these factors. So how are we going to get these things is that, now define velocity, rate of change of displacement. So if you divide this with the time, you are going to get. So we move in this direction where what we are doing, we are differentiating displacement with the time, you are going to get velocity. And if you move in this way, it is called as differentiating velocity with respect, because acceleration is the rate of change of velocity. If you divide this with time, you are going to get. So going in the right direction is the concept of differentiation. in the order of velocity, displacement, velocity and acceleration. If you want next from first, you have to differentiate. If you want to get next from this one, differentiate. And going in the reverse process is called as integration. If you integrate acceleration with the time, you are going to get velocity. If you integrate velocity with time, you are going to get displacement. These two methods are called as, by using these two methods of differentiation calculations, you can get from one to the other. By differentiations, you go to the next one. By integration, you are going to go to the previous one. And what all the job these two things done in calculus, the same things done is by slope and area in case of graphs also. What is that in case of graph? If you want to get velocity from displacement time graph, you have to take the slope of that. Or the question is, what does the slope of displacement time graph gives? Slope of displacement time graph gives velocity. What does the slope of velocity time graph gives? The slope of velocity time graph gives rise to acceleration. And in the reverse process, integrating acceleration with area of acceleration time graph gives what? The previous one, that is velocity. The area of velocity time graph gives integrating velocity time graph gives displacement. Going in the right direction is differentiation and slope. Coming in the left direction is these are two different methods. In the left direction is the integrations and areas. Let us try to confine our concepts to only differentiations to understand this. And what happens if you differentiate acceleration or slope of acceleration gives what? There is no such parameter called as acceleration by time. Accordingly, we call this as undefined. There is nothing existing like that. Nothing exists. No need to do the differentiation of acceleration. Also, what is the previous before this? Going back to the previous part. Again, this is undefined. That is, integration of displacement does not exist. Differentiation of acceleration does not exist. These are all the things what you should remember before going further. You can remember or pause whenever you want this video or recap it, because I don't want to repeat the same thing again and again. I'm just giving you in a one-line sentence or one-time sentences. Stop it and listen whenever you have some doubts. So I just want to give you and make you understand the same concept with an example again. Example means some kind of a problem, how we get a question based on the things what you have learned so far. You will be given a displacement equation like this. Displacement equation of a body is given by x of t, x as a function of time. If you are writing x of t, body is changing its position along x axis. You can also write y of t if the body is moving along y axis. And x is depending on what factors? X is depending on time. The meaning is that if you put t is equals to 0, x position is 7 meters. If you put t is equals to 1, you get some other number for this one. At 1 second, the body is at that. Means as time changes, position also changing. That is the meaning of what? X as a function of time, or x is a time dependent. Variable in this equation is time. So you have to differentiate this with respect to what? With respect to variable, which is time here, accordingly. So if this is a displacement equation in terms of time, you are asked to find velocity at 2 seconds and velocity at 4 seconds. And remember, we do deal with two kinds of velocities. One is called as instantaneous velocity, means at that particular instant of time. V to 2 seconds, we are calculating V instantaneous at 2 seconds. Instantaneous velocity we call it as. At 4 seconds, V instantaneous at 4 seconds we are calculating. Also, you are asked to find acceleration at 1 second, 3 seconds. Means again, instantaneous acceleration at 1 second, instantaneous acceleration at 3 seconds. And finally, we average between. Instantaneous is different, average is different. Between, the moment you say average, it comes between two different points. That is 2 seconds and 4 seconds. I'll just tell you the solution of this problem so that you can understand it easily. First of all, write a given equation. Given displacement equation is given that displacement x of t is equals to, what is that? 3t square minus 4t plus 7. Now we should know this thing. You are asked to find velocity. How to get velocity from displacement? Velocity is defined as rate of change of displacement, right? Accordingly, now that is the reason why we have studied differentiations. What you should do is that if you differentiate this with respect to time, dx by dt means differentiation of displacement with respect to time, or we now say that we should know that if you differentiate this with time, you are going to get velocity. And if you differentiate velocity with time, you are going to get acceleration. You should know that before going further. Accordingly, because I have taken that part previously, now and feel that you know that by differentiating it, you are going to get. Accordingly, what am I writing here? Differentiating above equation with respect to time. And how to write that one? D by dt is a symbol of differentiation, time variable, and what is the function now? X of t it is. And this gives rise to what? Velocity. This gives rise to velocity, which is equals to now d by dt of what is that we have in place of x of t. Write that equation 3t squared minus 4t plus 7. You have to solve this to get the equation of velocity as a function of time. I'll write here. Velocity as a function of time is equals to. Now, since you are dealing with the first problem, let me show you how to do the differentiation separately. First one, d by dt. What is the first term in that? 3t squared minus d by dt of 4t plus d by dt of 7. And I think in the previous formulas, I told these two formulas. I told for k into x also, but I did not tell you the formula for this one. D by dx of some constant number will be equals to 0. I did not add this in the previous formulas. You can add this. D by dx of kx is k. We have seen that. But d by dx of only without x, there is no variable in that, only constant number. If you differentiate a constant number, the answer is going to be 0. Accordingly, I have written all that steps separately for differentiation. You should know this. If you are differentiating this with time, you are going to get velocity. Therefore, velocity as a function of time is equals to d by dt of 3t. So that's the reason why we have seen formulas. What is the formula now? D by dt of 3t square means power will come to the first, that is 6 into t power reduced by 1. D by dt of 3t square is 60 minus d by dt of 4t is 4 plus last term is 0. Therefore, v as a function of time is equals to 60 minus 4. This would be our equation number 2, and displacement equation is going to be 1. But now we got second one from first displacement. From displacement we got into velocity. Now, using this formula, substitute at what time we want. We want to find out instantaneous velocity at 2 seconds and 4 seconds. Therefore, at the time t is equals to 2 seconds, v instantaneous is equals to, in this formula, substitute t is equals to 2. v at 2 is equals to, because we want at 2 seconds, 6 into 2 minus 4. What is 6 into 2 minus 4? 6 to the 12, minus 4 is 8. Units of velocity is meters per second. Similarly, at t is equals to 4 seconds, v instantaneous is equals to v4 is equals to, what is that? 6 into 4 minus 2. Substitute that time in this equation of velocity. If you substitute time in this equation, you are going to get displacement position. If you substitute in this equation, you are going to get that in terms of velocity. So this is equals to how much? 24 minus 2, which is equals to 22 meters per second. So the answer for this is 8 meters per second. For this is 22. Now we would able to find out velocity from displacement equation. Now what is there? We have one more thing. Acceleration. To get acceleration, what you have to do? A is equals to differentiating equation 2 with respect to time, we say. That is, what is that? D by dt of Vt is equals to A. You have to differentiate that. What is that? Again I am writing d by dt of 60 minus 4. What is d by dt of 60? Let me separate the things. D by dt of 60 minus d by dt of 4. D by dt of 60 is 6 minus d by dt of 4 is 0. This is units of acceleration is 6 meters per second. Now in this equation, clearly acceleration is not depending on time. Acceleration is not depending on time. Means we call that as uniform acceleration. If it is time variable, changes with time. If it is not depending on time, for any time it remains the same. Means what? Here you are asked to find acceleration at 1 second. Do you have time in that equation? No time. Accordingly, acceleration at 1 second is 6. Acceleration at 3 seconds is also 6 only. We now say that here the body moves with uniform acceleration. I am repeating. Uniform acceleration means which is not depending on time. For any time it remains the same. In this case, answer for these two values is that 1 second, 3 seconds is that 6 meters per second square. Now, I will give this as a work to you. Try this one. That is, find V average in 2 and 4 seconds. To find V average, there are two ways. Substitute 2 seconds in this formula, equation 2, you will get V at 2, 4, V at 4. Already we got that one. Average means take the average of this. 8 plus 22 by 2, which is equals to how much? 30 by 2, 15 meters per second. Average means sum of V1 plus V2 by 2. V1 is what? At this time. V2 is what? At this time. This is one way of finding the acceleration. Average. One more way of finding the average is that average velocity is equals to final position minus initial position by change of time. How much is the change of time between these two? 4 minus 2, 2 seconds. You have to find position at 4 seconds, position at 2 seconds. Substitute 2 here, you will get some position for this, which is called as initial position. Substitute 4 here in this equation, you get final position. Final position minus initial position difference, then divide with time, you will get the same answer. In this way, in this method, if I calculate, you will get 8 plus 22, that is 15 meters per second. You people can try by using displacement equation and check whether you are getting 15 or not, the same answer as that of this method or not. In this way, you have to understand the concept of differentiation. Any other part, slope, area or integration, I will check out I'll do that in the next video. Hopefully you understand this. If you want, you can do some more practice problems are there in the textbook also. The more you practice, the more easy it becomes. I wish you all a very happy learning. Go ahead with your proper preparations and all. All the best for your coming up exams. Thank you.